So what you've just seen is my entry for the programming. Starting here from the very first line, we have a hashtag include IOStream, which basically tells our compiler to use syntax from this library called IOStream. It's right here. So the include on the left side and the library to include on the right side, right? And basically using namespace standard here is telling us that the library called standard is the one that we wish to use in the code to come. And the reason why we include that is so we don't have to write the tedious syntax later on in the code. Well, moving into the main scope right here, we have 10 variables of different data types stored here. Beginning from the top, our integer, then our short int, long int, signed int, my char, or char for short, right? A float, double, and a long double, and a bool. And this is a combination of the first and second task of the programming challenge right here, because I both create the variables in this segment of the code, but also initialize them immediately and assign them values that are valid. So the values are, as you can see here, different for each variable, but they could have been anything that's valid to the different types we have here. The char right here, it takes the value 100, for example, and converts it into the ACI or ANCII index, so that we take the symbol that corresponds to the number 100 from there. So the float right here, they have the 0.5 behind them, and just a random number that I'm using, but the difference between the float and double here is just that one uses more memory than the other. So the double could in theory be a much larger number, right? And that's the same here with the long double, right? And finally, the boolean value set to false. It could have been true, but I choose false. This corresponds to 0 if you use integer numbers. So moving on to task 3 right here. Starting from the left, we'll be outputting something to the console using our namespace standard, and that's the cout. And what we'll be outputting is the value of my int, as you can see right here. It's just a string telling us some text, so it's just not a number standing alone, but with a string that actually explains what happens. These quotation marks are not used in the actual code. I haven't got a chance to remove them right now, because what you saw in the beginning of the video were this exact code. So I'll keep them for now, but actually they do nothing. I wanted them to make a space, but I already done that in the string to the left. So what is output is basically just the value that's contained in my int, right? And finishing with a break line. So we go to the next line where we'll be outputting again, following a similar method from the above. This time we just output my short int instead, or the value for it, right? In a similar manner with the string that first says what we are outputting and then the container. And same logic going down with all these different variables. There's something new here in the bottom though. The console output right here, it just says that we want a line of spacing between this segment of code and the code to come. So it doesn't come like in one line after another, but we get an empty space here just for convenience sake. Moving on to task 4 right here. Again, I'll be going through the first one, and the rest of them are basically just will just be me repeating myself. So we're outputting to the console once more, and what we're outputting is this string that says the number of bytes. Notice the space here right after the colon, which creates a space in our code. Before we I know this part of course, but before we output the size of my integer seen here, and that would be like how much memory in bytes that this container will be using. We want that to be outputted right after our string, so that's what happens here. In this case, for the variable my integer. So moving on, again, ignore the quotation marks. Then we have another string and the number of bits. In order to get the number of bits, we know that like 1 byte corresponds to 8 bits, right? So we take the variable my int, multiply it by 8, which should give us the number because it takes 8 bits to get 1 byte, right? And the same will happen in the 9 lines to come. However, the variable will differ. We'll be using my short integer, my long integer, my long integer, my signed int, my char, my float, my double, my long double, and my boolean. Using a similar approach as the first line, multiplied by 8 to get the bits, and just have the size of to get the byte. Moving on to task 5, I'll be demonstrating 3 ways of typecasting right here. Starting from the left, we output to the command prompt once more a string that tells us what we are outputting. Notice the space between the colon and the quotation mark in this string, which creates a space. And we'll be outputting, or we'll be converting into integer. That's what this part means. And what will become an integer is the variable my double, as seen to the right of this expression, which ends in a line break, which brings us to the next way of typecasting. So basically we will get the value for my double and convert it into the nearest integer value, which we'll be rounding down. What happens down here is exactly the same. However, this new expression, this one tells that my char, the value of my char, which was 100, should be converted into an integer rather than a character, or a char for short. So instead of having a arrow that points towards the left, we'll have it output 100. And with the final line here, exactly the same method. We'll be using the static cast to typecast, and we'll be typecasting into a character this time, as you can see here inside of these angled arrows. And what will be typecasted from another data type into a char will be the contents in the parentheses. That is my integer times 6. The reason why I'm multiplying it with 6 is because my int value is 10, which corresponds to a button on the keyboard, and we want it to be multiplied by 6, so we get 60 instead, which is a character from the index. We can actually see. Moving on to the last part right here, our task 6. Basically, we want to have a double, in this case a long double, list all of its digits after the fraction here. So 1 point, and then what was like 14 threes and 117, or 13 threes and 117. And in order to have it list all of the 15 digits, we'll be using this code right here. We'll be outputting with a precision of 15. That is to say that we want the longer double to be listed with all of its 15 digits, because if we don't do this, after this string here, this value will only output like 6 digits after the 1. But not in this case, as you can see if you go back in the program, because I've used the precision right here, we get all of the digits. Which brings us to the last part of our code, as I have highlighted here. We use the inverse pretty much of command out, which is command in, and we want to wait for the user of the program. We want to capture his keystroke, which is the part here, .get, and there's no specified value, so we're just waiting for any keystroke at all.